There we go. So an official good morning to everyone. Thanks for being here. Today is our final lecture. Wow, crazy, hey? So it's going to be, as you can see on the little screen here, it is going to be, we're going to talk about coding this morning. And so we'll do some notes. And I thought as a last set of notes, it would be nice to do them like our Mad Lib format. So we'll do that. And then we'll talk about, and we'll go to Scratch, and then we'll talk about the assignment, and then whatever time we've got left, it'll be yours to work with and work on this last project. But before I get started, any questions or thoughts or comments? No? Everybody's good? Okay. All right. Oh, Tiana, go ahead.
So this is our last lecture today. Like, we don't have lectures next week.
Next, so let's look at our good old calendar here for a second. So there won't be a lecture next week because all our topics are done. So if we look at next week, we've got the 6th and the 8th. So on the 6th, I'm going to make that a review period. So if you are interested in coming and doing some review for the final, we can do that. So during our class time, and then the 8th will be open, optional for anybody who wants to do anything they need to do. Okay, does that make sense?
Yeah, sounds good. Thank you.
Yeah, you're very welcome. And then with that said, we just go to Google Classroom for a second. So we are right here. I will just release this right now for us to look at. So first thing I just want to notice here, there is no checklist or rubric for this assignment. So you don't have to hand that in. Everything that you're going to hand in for this assignment will be like a physical file. And I'll show you that when we do the start the assignment. I'll show you how that all works. Don't forget, this is worth 10% of your overall final mark. Okay. And I think that's about it. And then there's all of these goodies that go here with a lot of these are just resources. So if you want to make copies of these for one day in your own classroom, if you're going to do this, like this whole Scratch manual box set thing here is literally like a set of playing cards that kids can take, and it gives them a little Scratch coding project on them. And there's just really mostly just stuff here that you can use or for yourself or with kids later on sometime when you have your own classroom. Okay, as far as the project in itself goes, we've got these instructions. Now, this is not a really complicated project, but when we start looking at, I'll just make this bigger here for you too. When we start looking at well, it's a little too big. We start looking at the notes, there is a lot of stuff here to sort of go through. But let me sort of simplify this whole thing. You are going to have, in the end, 10 files, and those are going to be tutorial files. And then you're going to work through those 10 tutorials, and then you are going to put in your 11th thing, I guess we'll say, that you will submit is your own project. So up here, it gives you a listing of all of the assignments or all of the tutorials, pardon me, that you're going to need to do. It will give you a file that looks like something like this. So if it's called Getting Started, it'll say getting started.sb3 and so on all the way to that. And then once you complete all of those, you'll create your own brand new project. But we'll talk more about that when we get there. Okay, so that is it for that piece. In the chat, I am going to throw up right now the Scratch coding notes. I can't even remember why I did it this way, but the notes are a Google drawing. Okay, they're not a Google Doc like they normally are. When you click that link, it should force you to make a copy of this file. Tell me, somebody, at least a couple people, tell me if that actually happens. It should work. Perfect. Thank you, Faye. All right, Tiana, thank you. All right, Talon, excellent work. All right, so it should make a copy of these notes for you. And I'll just give everybody a second or two longer to just make a copy. My options here. Let me just make that a little bit bigger. Wow, doesn't give you. I'll go really, really big. All right, so that should. Can you post the link? And oh, sorry, Christy, if you're late, you missed it. Sorry, you don't get the link. Sorry, too bad. And don't anybody post it for Christy. Don't be nice. Be mean. It's Christmas season. You should be cranky. All right. There you go, Christy. All right. So coding lecture notes or 010001 blah 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 blah, right? What are all those zeros and ones? What do they mean? Thank you, Jamie. That is binary code, and that actually is the binary code for these three words: coding lecture notes. That is what, as a computer, this is what a computer recognizes, right? A computer recognizes binary code, zeros and ones, and it is basically what they represent is on or off, which really sounds simple, right? And you think of all the complicated things that our computers can do, it really boils down to something fairly simple, okay, in a way. All right, so you should be, through the things that we have done with Stephen so far, you should be familiar with these types of little blocks that we work with, and this is Scratch. And Scratch uses these blocks. You can't, on the screen here, you can't drag them or do anything really with them because it's just a picture. But you will drag them, and when you move them close enough together, they sort of attach, and you create a whole bunch of code. And then things happen on your screen. So we'll get there right after we do the notes. Okay. Just going to make my version of the notes just a smidge bigger too. Oh, that's way too big. Okay, hold on here. All right. So first piece here says the 21st century is the something era. And that word is information era. Okay. And I think we could probably all agree we are inundated with information from everywhere we go. It doesn't matter what social media platform you're on. It doesn't matter what, whether you're on a television or you're listening to the radio in your car or whatever. We are we are inundated with information. So the next sentence goes on to say, machines are going to be smarter than humans, and coding will be a necessity to work with them. And I think we already are seeing that, all around us. Every single day in the news, there's something about robots. So there's something about automation, right? All of you, and I don't know about PCs, I would imagine it's probably similar with PCs and Chromebooks, but a Mac computer, if you're sitting there right now on a Mac computer, you have to know that when you ordered that Mac, if you didn't buy it directly from Best Buy or something like that, but if you, let's say you order it from Mac, but even Best Buy's Macs, every single Mac, when it's assembled, is not touched by human hands. It is touched by robots, right? So there's a whole assembly line with robotic arms and robotic stuff, and your Mac computer is assembled completely by robots and not by human beings. So it's kind of interesting. Now, of course, human beings do all the coding, right? All behind the scenes, because that robotic arm can't do what it's supposed to do unless a human being tells it what to do, right? So anyways, I think that's very interesting. The next line down where it says computers are part of almost every industry and are changing the way we live, right? Any of you, speaking of computers, you'll have, if you, any of you are looking around and, doing any kind of car shopping, if you drive, the next time you drive by a car dealership, you'll notice how empty some of those lots are. And the reason for that is because in your modern computer or in your modern day car, everything in your car is basically run by a computer, right? If you were to strip down your Mac or your laptop right now and bring out that little green board with all the chips and stuff on it, there's one of those inside your car that controls everything. And if you've ever had one of those malfunction or a brake, I'll use a brake, break in your car and you've had to have it repaired, you'll know that it's in the $1,200, $1,500 range to have that repaired, because it literally is just a computer without like a screen. And a lot of our cars these days actually do have screens as well, right? So anyways, so almost every single function in your vehicle is run by a computer, right? So which makes it is a little bit scary, I think, in some ways, that we have a computer controlling everything we do in the car, minus obviously, well, actually, I shouldn't even say that. I was going to say minus driving, but that Tesla and lots of other companies are working on driverless cars. All right. Equally, this is true in education, because computers and technology used to deliver curriculum and offer opportunities for students to interact with technology. So the blank there is to deliver curriculum. Okay, so every time you have kids out there typing away on their computer or on their laptop or whatever device it is that you're using, right? You're delivering curriculum, right? Even just for the fact that they've cracked open the laptop's lid and they started typing, that's an ICT curriculum outcome, right? So without even assigning them like something else from math or science or social, just the fact that they're on the computer is satisfying a curriculum outcome. Okay. All right. The next one down says coding involves problem solving, perseverance, collaboration, mathematical logic, and reasoning skills. And you're going to see that when you start working on these Scratch projects, especially problem solving. Is you'll put some of those bricks together and you'll say, okay, do your thing, and it won't, or it might not do all of it. And you're going to be like, darn it, where did I go wrong, kind of thing. Okay, so that last blank was coding involves problem solving, and then the rest of that stuff. So the next one down, oopsie. I'm just going to scroll here on my notes here, right? Like so. All right. Coding is a process of creating instructions. So that blank is instruction. So coding is a process for creating instructions for a computer to follow, right? A computer, at least right now, computers only do what we tell them to do, right? And so coding is a process of creating instructions for a computer to follow. These instructions are a type of language that humans use to communicate with machines. Okay. All right. Almost all of the technology, so that next blank down right here is technology we use today has been created with computer programming. Our apps, computer programs, video games, and even the technologies in our cars rely upon coding. Okay, so this one's cars. All right, next one down. Digital skills are tools of empowerment. And if we think about Maslow's hierarchy of needs or William Glasser's hierarchy of needs, remember power over one's sort of destiny is a human need, right? So once you teach kids these skills, that is a form of empowerment. All right, digital skills programs will prepare the next generation for future jobs. And so when we talk about an organization like CanCode, which is a federally sponsored computer programming, learning how to computer program, what happens is we are preparing that our kids for that next generation of whatever's going to happen with computers and robots and all of that kind of jazz. Okay, and for jobs that are going to be in that industry. Okay, the next one down. Let me just scroll a little bit here. There we go. Many jobs today rely on the ability of Canadian workers to solve problems using digital skills. So this blank here, darn it. Where did it go? Right, there we go. Right, this blank right there is Canadian workers to solve. Okay, our government, so next one down, our government is investing in a program that will equip young Canadians with the skills they need for a future in which every job will require some level of digital ability. So we've got here digital ability. Okay. Coding teaches our young people how to work as a team to solve difficult problems in creative ways. Okay, so creative. That's how they will become the next great innovators. And here's a spelling test word for you: entrepreneurs that Canada needs to succeed. So again, with that little statement, you can see why the Canadian government is investing in children now, because we know that they're the future, and our country and our prosperity and freedom and everything will rely on the future, the kids that we're teaching today, right? All right. Next one down. Scratch, and Scratch is one version of what they call block programming. So, and what I like about it is it's free. So, and there's no cost. It's not like, well, it's free for, this much, but then after that, you got to pay for it. It's not like that. It's just free. So it's kind of cool. Okay. So Scratch promotes right here, Scratch promotes computational thinking and problem-solving skills, creative teaching and learning, self-expression and collaboration, and equity in computing. Let me read that all over again. Scratch promotes computational thinking and problem-solving skills, creative teaching and learning, self-expression and collaboration, and equity in computing. Right? So it doesn't matter who you are. And when we talk about equity, it doesn't matter whether you're a boy, whether you're a girl, or how you identify. It doesn't matter. It doesn't matter whether you're young or you're old or any of that stuff. That equity piece is there, right? It doesn't matter if you can know how to keyboard and you learn some type of computer language. It doesn't matter who you are. You can do it. Okay. All right. Students learn to think creatively, reason systematically, and work collaboratively. And if you look at all of these words that I'm using right now, all of these adjectives, these are the skills that employers are asking for now, right? They want people that can reason. They want problem solvers. They want people that can work collaboratively and get along with others and all of that kind of stuff. Okay, so the next blank here is, again, students learn to think creatively, reason systematically, and work collaboratively. These are essential skills for everyone in today's society. And if you go to a place like Industry Canada and you ask them, or you check and see what they're looking for in their employees now and future employees, is all of these types of skills. Most employers are not, especially in industry, are not always interested in that you have a degree in whatever, because what they want is that if you got to press these buttons and turn these dials and make something happen, employers will say, I can train anybody to do that piece, but what I can't really train into somebody is their ability to get along with others, or their ability to work as a team, to be a leader, all of those kinds of skills, those interpersonal types of skills, those are the ones that they can't teach people, right? So, this is all really, really important stuff for not only us, but also for the kids that we teach. Okay, so understanding computers and learning the basics of coding helps children to develop an appreciation of how things work. So that inquiry-based learning, problem solving, project-based learning, things like that are all things that we do in the classroom that help children develop those skills that we've been talking about so far in our notes that are important. Okay, here's a little bit of another spelling test word. An algorithm, right here, is simply a set of instructions given to complete a task. Okay, so a set of coding, instructions given to a computer so that it'll do something. And that might be just something as simple as, taking the first letter of your first initial or first letter of your first name and making it, turn around on a computer screen. That is a set of instructions given to the computer to make that object do whatever it is that you want to do. Okay. All right. Let me just scroll down a bit. Where are we here? There we go. Perfect. All right. So 10 benefits of learning to code for students that go beyond the computer. Okay. So number 1, computer programming promotes logical thinking. And I don't think there's any of you that are out there right now that would say that this is an important skill for kids to learn, right? So computer programming promotes logical thinking. Number 2, learning to code helps a student's creativity, right? And if we think and we go back and we think about Bloom's taxonomy, that's exactly where we want to take them, right? We want to take them from the low level stuff all the way up to that creative part where they're at the top of Bloom's taxonomy. All right. When students learn to code, so number 3, when students learn to code, they develop persistence. Right? It didn't work. Okay, so now what do I got to do? Oh, I got to change that. So I changed that. Man, still didn't work. Now what? So it's that stick with itness that we're looking at, is not to give up, right? So when students learn to code, they develop persistence. Number 4, coding helps to develop resilience, right? And if you're anywhere near a school system these days, K-12 for sure, you'll hear that word about resiliency and building that in kids, right? So very, very important. Number 5, let me just scroll down my notes here a little bit. There we go. Number 5, learning to code can improve a child's communication skills. So number 5 was learning to code can improve a child's communication skills. Number 6, children improve their structural thinking when learning to code. Okay. And we might even be able to substitute the word into hierarchical thinking, right? Because there are steps that need to be followed for things to work properly. Okay. Number 7, coding helps children with problem solving. Okay. And you're going to, like I said, once you start this, you're going to see that yourself, that especially for the final coding project, the number 11, where you're making your own Scratch program where that problem solving and that persistence is going to be important. Okay. Number 8, coding improves students' math skills. All right, so it improves students' math skills. Number 9, coding gives students, and again, you're going to find this out, satisfaction, especially when it works, when you click the button to say, let's check this out and see if it's going to work, and it works. That is, there's a deep level of satisfaction. Okay, and then number 10, it says coding helps kids to learn. So coding helps kids learn to learn. All right, let's scooch on down a little bit. And so I mentioned this word before, and I'll say it again here. Silly thing. Block-based coding is coding with a programming language where the instructions are represented in blocks. For example, Scratch. Okay, so again, it's block-based coding. Okay, all right. Now, if we scooch on down here, it says many times during a coding project, students need assistance to troubleshoot their program. And so that's why, remember my rule about we don't ask kids to do things that we haven't done ourselves already. So this is really important there, is that when a student puts their hand up and goes, I can't get this to work. I've tried and tried and tried, and what's wrong with it? Help me. That's where it's important that, you know, at least have a little bit of a background and a little bit of knowledge in what's going on their screen when we talk about Scratch coding. Okay. All right. Students will turn to other programs or online documentation to assist them with their problem and program completion. Okay. And that really, if any of you or have kids out there who play video games and they get stuck on a level, you know, that's exactly what kids do these days. They'll go online, they'll find either a video help or a text walkthrough or some type of help online for them to solve their problems. Okay. So again, students will turn to other programs or online documentation to help them complete what they're doing. Okay. In this case, students must respect the intellectual property rights of others by giving proper credit. So just like when you say blah, 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 and you cite it, you know, Shakespeare, you know, whoever it is, you know, whatever year, it's the same idea, because people can copy other people's code, right? And I'm sure you've read in the news where one company, Apple's suing another company because they stole their code or they stole something. And so it's the same idea. So that, you know, goes back to that whole idea of digital citizenship again, where part of digital citizenship is recognizing the intellectual property of others and not stealing their stuff, right? All right. This is following the digital golden rule and demonstrating, like I just said, digital citizenship. All right. Believe it or not, that's all the notes there are. Okay. And then again, just some other little programming things at the bottom. And if I scroll down a little farther, oh, yours doesn't have that on it. That's okay. Okay. Now, what we need to do next is we need to go, and I'll throw this up in the chat for you. We need to go to Scratch's website. And I'll just put that in the chat for you. There you go. And what I want you to notice right off the bat is who sponsors this computer programming site. And that is MIT, right? The Massachusetts Institute of Technology. And you know that people that go there and the people that work there are generally usually very smart people. Okay. Okay. Is everybody okay? Everybody on the same screen I'm on? If you're not, let me know. Good. Thank you, Jessica. All right. Okay. So what you're going to want to do is you're going to want to click Join Scratch. And you are going to have to do a username and your own password. So you're probably going to want to write this down, or unless you're just going to use one that you use, you know, before, you're going to want to do that. Okay. I don't want to do that because I already have an account. So I'm just going to go sign in and do that. And it will take me into my Scratch window. So once you do that sign in process, you should get to a screen, I think that should look like this. I'll give you about a minute or so here to figure it out. Is there anybody that is not on this screen or having problems? Is everybody good? Okay. All right. So just on this screen, of course, this is just stuff that people have done. Adults, kids, who knows? Okay. But what we're interested in here is to go to create. And once you hit create, you get a screen that looks like this. Okay. Now, one of the other things, so this is Scratch. This is the web-based version of it. If you have a Mac or a PC, and I'll just pop up my little tray here, there is actually a Scratch program that you can download as well. So if you don't want, and I would advise doing this in a classroom if possible, especially if you don't, because otherwise we're relying on the internet or Wi-Fi, right? So, and I'm just going to click the Scratch program just to show you for a second here. There we go. Scratch is loading. And you'll notice you get the exact same screen. I can make it bigger here a little bit, but you get the exact same screen as you do on the web. So if you don't want to rely on the internet, downloading the program is a great idea. Unfortunately, I am not aware of like the program or the app version for anybody on a Chromebook. Okay, so but if you've got a Mac or a PC, laptop, or computer, definitely you can download the app. And as a matter of fact, when I check your projects, I almost exclusively just use the app and don't go online. Okay. All right. So here we are. We've arrived. And again, if you can think back to some of the stuff that Stephen has presented to us, these little blocks along the side, and if you scroll down, hold on one sec there, Ricky. If you scroll down, you'll notice that there's all kinds of things that it can do, and also it is computer coded, or color coded, sorry. And why that's nice is you might have a student says, I can't get this to work. It won't, I don't know, it won't pause for 2 seconds before I want it to do the next thing. And you could say to a student, you know what you need to do is go down to the purple ones right here, the looks, and the problem to the solution to your problem is within those purple blocks. Ricky, go ahead. What do you got?
Sorry, I just missed the beginning trying to get myself all logged in there. Did you just go to create? Is that all you're in right now?
That's all we're in right now. Yeah.
Okay, perfect. Thank you.
You betcha. For sure. You're welcome. Okay. So anyways, you can see that there's all these different color blocks. And if you click the color, it'll just automatically take you there. So, there to there, that kind of idea. Okay. All right. So if we go across the top, there's the little globe. If you download that, if English is not your preferred language, you knock yourself out with whatever language works for you. Okay. All right. And then we've got file, right? Save now, save it as a copy. And so it's important to know that we need to come up here and might have to do some saving, or when you want to create a new project, click new. Okay. And then the bottom two is load from your computer and save to your computer, right? So again, if we go back to our notes for 1 sec, you don't have to all just go back. Well, right here, right? When you say load to or right here where you say save to your computer, what you're going to get is a file that looks like this, and whatever name you happen to give it, right? But it will end in SB3. And then what you're going to have to do for this project is what you need to do is you will email me to my EDU email address all 11 of those files. So your 10 practice files plus your 11th file called Project 11. Okay. All right. There is just a place here, a name bar to do, to name your file, right? So we don't want to have untitled 1, untitled 2. What again, you'll name them, or what I should see are these names. So if it's going to be getting started, then up here, it's going to be called getting started. Okay. And then of course there's a share button. We're in this age of sharing with the world. And when you click share, you don't have to do this. If you want, you can. You'll get this window, right? So whatever program you just made will appear in the window. This is critical and so important, is to put the instructions on how to make your program work, right? So it's very important that and you'll see that once you get into the instructions for this project, is that I want those instructions for your project 11. I want the instructions on how to make it work. And if you don't give me good instructions, that may cost you marks in the end, especially if I can't figure out how to make it work. Okay. And then there's notes and credits and all that kind of jazz here. Okay. So you can then, and you don't have to do this, but you can go add to Studio, or you can copy the link and share that with other people. Now, I'm going to show you here in a second. So whatever little computer program you have here where the little cat is, right, is so if you share this with other people, they can click the see inside button and then see your coding, right? So there might be something really clever or really cool or interesting that someone's done with their program. And you're like, how did they do that? You can click the inside button and then see what they did to make it do whatever fancy thing it is that you want. Okay, so I'm just going to hit the back arrow just to get back to my create screen. Okay, and then as we continue along this blue bar at the top, it says see project page. That just takes us back to the same idea. Okay, and here, if you click this little file folder, you'll see that it'll give you all of the different Scratch programs that you have either made or that you have copied or used from another person. Okay, and I'll just show you. This one's always very popular, right? Is to click that, and so on this one there are no instructions, but I'll click that, and then just see without instructions, you're like, okay, now what do I do? I can't even remember. So it doesn't matter. But you'll see why instructions are really important to put over here so that people know, how do I start the game? Do I press space bar? Do I press an arrow? Like, what do I do to get it started? So those instructions are really, really important. And they're equally important for it to sort of drive that thing home, that idea with your students as well, is if they're going to share them, that they put explicit instructions. Even if you're just sharing it within the classroom or they're sharing it with you, you need to know how to make the program work. Okay, now on Scratch's website, I'm just going to go back there for 1 second here. Hold on, let me just grab that website again. Where the heck is it? Oh, here we go. All right. Why can't I find that? There we go. I think I got it figured. Yeah, there we go. All right. I'm going to give you the direct link here so you don't have to do what I just did. I'll just put that. I'm just going to bring that onto the main screen as well. And then in our chat, I'll throw this link. There it is. Let me just give it a title here. Scratch tutorials. There you go. Okay, click on that link, and it should take you to a screen that looks like this. Just got to grab one more drink here. It doesn't work for me. Okay, well, all right, then I'll take you through it the long way around then. Okay, hold on here for a second. Hold on. All right, let me just go back here to that screen. All right, so if you go back to, like, from here, if you just go back to the main screen by clicking on the little Scratch button here, it'll take you to this screen. Okay, and then what you're going to do is you're going to scooch on down to the very bottom, and you are going to go down to resources, and you're going to go, can't remember, was it FAQ? No, back up. It was ideas. Okay, so again, I'll just do that one more time. You scroll down to the very, very bottom of the main Scratch page, and you go to ideas, which then will take you to the tutorial page. So then if you click choose a tutorial, it brings you to this page. Is everybody good? Is there anybody having problems still? Everybody's okay? All right. So if I go back to the Scratch instructions, you'll see here where it says getting started. So if I go here, there is getting started. So let's everybody click on that, please. Okay. And when you click on that, you'll get a scratch window, and you will get this tutorial. So there's two ways to do it, and whatever preference you want, and just watch for a sec before you click. Is you can watch the video, or if your other preference is not to just watch and watch the video, and none of these videos are very, very long, right? So if you wanted to watch the video, it's probably 30 to 60 seconds maximum. Okay. But what I prefer to do is I prefer to click the arrow, and the arrow then will say, it will walk you through every single step. So if you look here, what it's saying is to go to the motion blocks and click, hold, and drag the move 10 steps block onto the main canvas or the main area where you do that. So go ahead and do that for me, please. Okay. Now, if you click the arrow again, it will tell you what to do next. It says to go to the looks blocks and say hello. And again, you're just going to drag it on the screen. Say hello for 10 seconds. And then what you're going to do is you're going to move it up to the blue block and make them join like that. Okay. So whatever is in this box right here, or this little bubble, it will say that on the screen, and it'll say it or it'll have it up on the screen for 2 seconds. So again, you could change this. It's same thing here, move 10 steps. You can do the same thing. You can move 10 steps or 20 or 30 or how many ever you want. Okay. If we click the thing again, click the green flag to start the program. And the program window is right here. So if I come here and click the green flag, oh, I don't think anything even really happened there. Hold on for a sec. Why is that? Click the green flag to start. I'm just going to move my little guy over here. Well, that's a bummer. I don't know why it didn't work. I'm going to change that to...
Do we have to drag in from the yellow? Like drag in the yellow?
Oh, yeah. Sorry, my bad. Sorry. Yes, you got to go to events. Thank you. And you got to add the when clicked. Thank you, Ricky. It's early in the morning here. And then you can see what happened. And nothing super exciting, right? I can move him back, click that, and he moves 50 steps, at least according to the program. Okay. One of the things that I want, and then you can click the stop sign to make your program stop doing whatever it's going to do. Okay. And so often when you're going to, especially when you're working on the program, the one that you're going to create yourself, is you might have this many blocks and it might repeat 10 times in a row. So if you're like, okay, it works fine, I don't want to wait all 10, repeats, you can just hit the red stop sign to stop the program. But what I want to show you that I think is important is whenever, by the way, these little characters, this little guy's called a sprite. Okay. And the position of the sprite is up to you. You can drag it and move it around on the screen. Okay. But you will always have a starting point for whatever it is that you're doing with the program. What you need to sort of know here is this, again, this is where the program will kind of execute. But down here is the name. So you literally could change the name of that sprite if you want. But what's important, and what I do is I actually write these down, is the location on the X and Y axis. So if you think of a graph, I'm sure you're all aware of X and Y axis, there is a starting point. So on the X axis, on the horizontal axis, it's minus 176. And then on the vertical axis, it's minus 11. So that's my starting point. Because once you start to kind of get going here and you execute your program, your sprite may not even be on the screen anymore. And you're like, okay, whoa, I need them back there because I want to try it again. And knowing those numbers is really important. Okay. So again, just wherever you put them, those numbers will change, right? So again, if I put them down here in this bottom corner, you can see the numbers here have changed, right? So there was my starting point about there. Okay. And then down here below the next line down, it says show or don't show. So if I say don't show or show, it'll make your sprite appear or disappear. I'm not sure why I would use that. Can't think of a time I have. And then also it will give you the size of your sprite. So if you change that to 500, you can see he gets quite big, right? And then let me make it a little bit smaller. Let's go 200. Okay. So now I've got this bigger sprite. The other thing that you can do is change the direction of where he starts. You might, again, depending on what you're doing, you might want him to start upside down, and then you make a computer program. So the program, and when you execute it, it will rotate him and make him be back, sort of normal. It could be that. Okay. So these are sort of your controls. I'm just going to go back to size 100 for 1 second. Okay. And then the other thing that you can do in this window is right here in this corner is you can choose or add different sprites. So if I click that little cat sprite, you can see that there are different ones here. What I recommend, it's not always easy just to scroll through and find it, but you can use these tabs or these buttons at the top to get to different ones. And one of the ones that you're going to end up doing is letters, and you can illustrate your name. Okay. So if I go back to my main screen here, and let's keep following the tutorial, right? Add a backdrop. Okay. That is right here in this window. And this one, they've got sort of like a volcano or whatever in there. So honestly, it doesn't really matter which one you choose. You can choose any one you want. I'm just going to choose Arctic. Okay. Then it gives you an Arctic background. Okay. Add a sprite. So that's right here. We can add a sprite. And it really doesn't matter to me which one you add. I'm going to add, what am I going to add? How about a crab? There we go. So I'm going to add a crab. Okay. And so for this tutorial, that's all that you do. Okay. So now you are done this tutorial. So if we go back to our getting started or our instructions, getting started is one of the tutorials that you needed to do. So we just did it, right? So then what you need to do is you need to go to File and say Save to your computer. Now, remember when we save to our computers, it's important to know where it's going to go. So I know mine always go to my desktop. So yours will either go to your downloads or probably your document folder, unless you've changed it. So I'm going to go save to your computer. Right down here, it shows me that it's untitled 4.sb3. If I scoot on over just a little bit, you'll see on my screen right here is my SB3. Now, it didn't name it Getting Started, so I want you to do that and name it, Getting Started.sb3. Now, the one thing also that you need to be aware of is on your computer, if I double click that, nothing will actually happen, but I could choose the Scratch program to make it work. And I'm not going to do that because there's really nothing that I want to do with it right now. And then when I get this from you, I will download it to my computer and I want to see if it works. Now, whether I'm in the app or whether I'm in the web-based app, if I go File, load from my computer, it'll say, what do you want to load? And I'll say, I want to load that Getting Started file. And if I double click it, right, replace the contents of this current project because I'm in an active project, I'll say yes. And then it loads that. It doesn't look like anything happened, but it did. And it'll load that program. And then, of course, at the very end, when this one says Project 11 and I load that, that's the one that I'm really going to mark for you. And so that's where you're going to show me that you actually learned something. So if you go back again to the instructions, it doesn't really matter what order you follow these in, but I did sort of put them in from easiest to kind of hardest. So if you follow it alphabetically A to J, you'll work your way through the tutorials. And here's also a tutorial button up here. We can go back to it. Okay. So the next one after that was Animate a Name. So then you would go here and choose Animate a Name and work through the program. Now, that's it. I literally cannot really teach you much more from this point. Okay. So what you can do, what time is it here? It's 10 to 9. So we got about half an hour of class left, is if you want to play around and work with a couple of these tutorials, and of course, if you encounter any problems, I'll be here for you I'll be here to help. But basically, we're at the point of the class where I'm going to say, if you want to head on out, you can. If you want to stick around, I'll be here till 9:20. And of course, if you leave and you want to pop back in, you can do that. So before I sort of say head on out or whatever, let me just answer Christy's question here. Christy, go ahead.
I was just wondering, in the videos, like so the first one where it says getting started, it gives you different options where it says, like, you can animate a sprite. Do you have to do everything that it tells you in there? So like
Yes.
everything
Yes.
where it says then, okay, so you have to add the sprite, animate the sprite. So everything that it says in that tutorial, you have to do.
Absolutely. Yes.
Okay. Thank you.
You're welcome. All right. Anyone else? Okay. So the rest of the time is yours to work or do whatever you need to do. And I'll just stick around and I'll probably just play around a little bit. I haven't played with it for a while. So thanks, everyone. And we'll catch you. If you head on out, have a great weekend and we'll catch you next week. Okay. Thanks. I'm also going to stop the recording right now too. So we don't have just a bunch of dead space for people to watch later on.